Okay, we're learning how to help students to be able to divide decimals using the long division format. The end goal is to have something where the students can figure this out, a problem like that. And that's the end goal, but we have several steps to get there and several days, several lessons to do that. The first thing we want to do before we even begin on this is that we need the students to remember what division means, what 36 divided by 4 means, because they need to be able to use manipulatives to figure out the problems when they do it with decimals, because they can't do it this way with decimals. That's what we're teaching. So we need them to be able to figure them out using the base 10 blocks as decimals, and then be able to find answers and then look for patterns. So we begin with 36 divided by 4. There's two different ways we can look at this, two different models. One is to see how many groups of 4 there are in 36. So the students could either take these models, and they need 36 of these. This is the whole in this case. This is a tenth in this case. And the cubes are 1/100th or 0.01. So they either need 36 of these and divide and see how many groups of 4 they could take out of 36 of them, which I don't have that many here. Or what they could do is they could draw 36, so on like that, draw 36, and then grab all the groups of 4 and see how many groups of 4 they could make. That would be 9. That's one way to do the problem. The second way is to look at, again, having 36 of these blocks or 36 items, 36 wholes, and breaking them into 4 groups. Okay, so if we have 4 groups, so if I have 36 of these and so on, 36, and I'm going to create 4 groups, I'm going to put them all into 1, 1, 1, 1, and then take the next one, and so on, and take them till I exhaust all of these in here, and I don't have any more of these. What I'll find is I'll have 9 of these little blocks in each of the groups. So 36 divided into 4 groups. And that's the model we're going to use. We're going to come back to the other model later at the very end of this unit, but that's where we're going to begin. So the students have to understand 36 divided by 4, or anything, 12 divided by 3, for example, that we're looking at groups. 36 divided into 4 groups, 12 divided into 3 groups. So having that, remind the students of that conceptual understanding, either through the concrete or semi-concrete representations. I could ask the students to represent 3 2/10, or 3.2 sometimes said, although academic language would say 3 2/10. Okay, and that's this amount right here, 3 wholes and 2/10. And I could ask them to divide it into 2 groups, 2 even groups, or divided by 2. And this is the first time they're actually taking a decimal and dividing it, but they're doing it conceptually. So we have the 3 2/10, and they can do it various ways. It's not all that important. They do it in a certain way. For this exercise, they might say, okay, this group gets this one, and this group gets this one, and we got to split this one, so I'm going to have to exchange this for 10 tenths. Okay, so that's the same amount, and now I can continue to split these, 5 here, 5 here, 1 here, and 1 here. And I can see the answer is each group gets 1.6 or 1 6/10. Okay, so the understanding the conceptual way of solving this problem allows me to find an answer at this point. So I could do the same thing. I could begin with 1 2/10 and divide it into 4 groups. Okay, so I begin with 1 2/10, dividing that into 4 groups. Okay, so this here, I can't divide it 4 ways. So again, I'm going to exchange it for 10 tenths. And now into 4 groups, well, this group would get 1, and this group would get 1, and this group, this, this, and I've got these 2 left over plus these 2 I had from before, and I can break those up, and I can see each group gets 3/10. So 1.2 divided by 4 is 0.3. Okay, so solving these conceptually or semi-concretely. I could use concretely or semi-concretely, but both methods are conceptual, understanding where this is coming from. I could have the students try again another problem like 3 45/100 and divide that 3 ways. And just doing the same thing, which I'm not going to go through this one here, 3 45/100. Okay, and what they're going to find is that, of course, you can see everyone's going to get, every group, all 3 groups are going to get 1/10, so I know 1/10 is in there. These will be all taken up then, and I can see that here everyone's going to get, I'm sorry, 1 whole, not 1/10, 1 whole. And then here I've got the tenths, I've got 4 tenths, so I can see each is going to get a 10th. So 1/10 is going to be in all 3 groups. And then this is what I have left. I have 10 of these, 11, 12, 13, 14, 15 of these. I'd have to exchange this for 10 little cubes, 10 hundredths. And I can see that if I have 15 of those little hundredths, that divided by 3, each would get 5 of the little cubes, 500. So I can get an answer that way. Okay, so right now all we're doing is trying to figure out what the answers are with decimals, when we're dividing with decimals. In all these cases, if you notice, the dividend, the first number, is a decimal, and the divisor is always a whole number. Okay, so if I want to transfer this to a long division format, I could say, how would I write this problem as long division? And of course the students could they know how to set up the long division format. They've never solved it this way before, but you'd say, okay, pretend like that decimal point isn't there. How would you divide 32 by 2? Just imagine it's not there. Even erase it if it makes you feel better. And so 32 divided by 2, 2 goes into 3 once. Okay, and what I notice is that my answer here is 16. My answer here is 1.6. Okay, so this long division, what we've been doing since maybe 2nd grade or 3rd grade maybe, we've been doing this long division format. It gives me the correct digits. Okay, now if I ask them to put the decimal point back in, okay, I'm going to have them put it in there, but we're going to kind of leave that there, see if they can find a way to use this long division format to get the right answer there. They're going to find that this keeps happening over and over. If I take 1 2/10 and just write it as 12, I divide it by 4, I get 3. So again, I'm getting the right digit. If I put the decimal point in there, I'm setting them up to analyze this, and the third one. 3 45/100 divided by 3, pretend like it's 345. Okay, so again, I'm getting the right digits. If I put that back in there, it's not too hard for the students to see that all I have to do, I can solve all these problems. Instead of with manipulatives or pictures, I can solve them using the ideas that we had known prior to today's lesson. I just have to account for that decimal point, and it looks very much like all I have to do is put the decimal point directly above where it shows up in the problem, in the dividend. Okay, so the students are seeing this, the students are telling me this, so now it's time for me to test it. So maybe I'm going to test it with a problem like 2.54 or 2 54/100 and divide it 2 ways. Again, ignoring the decimal point, what would you get? You get 127. Put in the decimal point. They say you put the decimal point right above where it is there. So 2 And 5400ths divided by 2 should be 1 and 2700ths. And then I'm going to check it to see, really, does this thing work? So there's 2 wholes. And 5400ths, I'm going to divide it into 2 equal groups. So this group gets 1, this group gets another, this group gets 2/10, 2/10. I've got this, I've got to exchange that for 10/100ths so I can continue to divide it. Okay, so I've got 10 and 5, or 10 and 4, 14. So I can put half of them here and half of them here. And I can check that. My answer is each group has 1 and 2700ths. 1, 2/10, and 700ths. And that's what this algorithm that we just developed together as a class came up with. So that would all be one lesson. And it would definitely carry over probably into a second day. And we're looking at, like a 5th grade class or a 6th grade class. So this will carry into the next day, now practicing this. And maybe checking sometimes with the base 10 blocks to see if it really works. And so that's one step in this process of getting the students to divide a decimal by a decimal using the long division algorithm that we're so familiar with as adults. Okay, the second thing is we're going to need to set up some kind of patterning, because when we do the long division algorithm with a decimal by a decimal, such as our algorithm moves this over all the way until you get a whole number, and we move this over the same amount, and then we make the division. Well, what allows me to do that? I want the students to understand where that's coming from before we use it here. Okay, so I'm going to begin with a problem like 1500 divided by 300 and ask the students to figure this out. Using a calculator here is very appropriate because the students know how to do this. Again, we're in 5th grade, maybe 6th grade, and the students know how to do this. And to save class time, I might just say, put it in the calculator, what do you get? Okay, so you get the number 5. Now if I say, take these, both the dividend and divisor, and divide them by 10. In other words, change the problem into 30 into 150. Now put that in the calculator, what's the answer? 5, same answer. What if I take both of these and multiply them by 100? Put that in the calculator, what do I get? Again, I get 5 as an answer. So basically, I would ask the students, okay, so what's happening here? What can I do to the dividend and divisor that is not going to change the answer? And of course, I want the students to say, well, you can multiply both of them by 10, or divide both by 10, or multiply both by 100, or divide by 100, something like that, that the answer is going to stay the same. I would want to ask them why they think that works. Okay, get them to think mathematically. And basically something like, well, you're making the dividend the amount that you start with. In this case, you're making this 10 times bigger, but then you're dividing it into, rather than just 300 groups, you're making this, the number of groups, 10 times bigger. So you're kind of offsetting it. So you're making the amount that you're going to divide 10 times bigger. You're making the number of groups 10 times bigger. Or you're making the amount you're dividing 10 times smaller when you come down from here to here. And you're making the number of groups 10 times smaller. Okay, or 100 times bigger, both. Okay, and so that's kind of getting them, they're thinking mathematically. We would try this not just with this problem here, but we would try other types of problems like 38 divided by, maybe doing something like 38 divided by 2 and just working with this. So 380 divided by 20, 3800, 20, and so on. Okay, where they're going to keep getting the same answers. Okay, whether I take this problem here, I divide them, dividend divisor by 10, or multiply it by 10, or 100, or 1,000, or any multiple of 10. Okay, that's a skill that they need to learn. That's going to be the one that we're going to use to complete our division of decimals. Okay, and that might be a whole class period. It might be the better part of one. So now we're going to go back and review what we had done before when we were dividing decimals. Like, for example, we had divided 3 2/10 divided by 2. Okay, and I'd want them, and of course they know to do this, or maybe they need a reminder to do this, and they ignore the decimal point, and they just go ahead and then they put the decimal point right in there. And of course I'd want them to use the base 10 blocks, or some kind of like computer program, or semi-concrete model such as having 3 2/10 there and breaking those into 2 groups. Okay, this goes into one group, this goes into one group, and this turns into 10. Okay, so now I take these 5, put them here, these 5 go into there, and 1 here and 1 there, and sure enough I do get 1 hole and 6 rods, 1 hole and 6/10. Okay, so they do that one. They try maybe another one. Okay, and again, I really am more concerned right now with the conceptual way of solving this. So to take 3 45/100 and divide that into 3 groups. Okay, and let them do that. It's not too difficult. They've done this before, but I need them to do it conceptually. Okay, now comes the time where I'm going to give them a problem that I don't expect them to be able to solve. Give them a question I don't think they're going to be able to solve. And I might say, okay, you know, so far so good. How about if I divide 3 into 0.5? Can you do that? So they take out the 3, and I need 0.5 groups, and that's odd. You know, what's a point? What's half a group? You know, so the students, I would expect them to have difficulties right here, and that's what I want them to do. And I might say, okay, what's the problem? I mean, what you were doing these so easily. What's the difference between this and this? In other words, they're going to use the higher levels of Bloom's, look at this analysis and evaluation, and look at that and say, well, you know, up here we had whole groups, like 2 groups or 3 groups. Here I have half a group. I don't know what to do. Okay, so maybe I'm going to say, okay, well, here, let's try another one. So take 2, and now divide them into 0.2 or 25 or 25/100 of a group, or 1/4 of a group. And again, that's the same problem. Okay, so it looks like I need whole groups here before I can go ahead and do this, and that's what I would expect most, if not all of them to see. Now, here's the point where I want to go back to that skill that we had just learned, hopefully the day before, in which we noted that we could take a problem like this here, and the answer is 5, and we could multiply both of these by 10, or multiply both by 100, or divide both by 10, or divide both by 100, whatever we wanted to do. So if I multiply both by 10, for example, whatever we do, we get the same answer. Okay, so in this case, we're taking the amount that we begin with, 1,500, and we're making it 10 times bigger. So we have 15,000, if you want to think of these things. We have 15,000 of these rather than 1,500. And we're going to break that not into 300 groups, but 3,000 groups. Okay, but that I can do if I had 15,000 of those. I could do that. That I understand. How can I use this skill here with this here? Like, let's look at this problem right here. How could I use that for this here to turn this into a problem that I can figure out, yet I know if I use this idea here, the answer is going to stay the same. In other words, whatever answer I find when I change this, it's going to be the correct answer. Okay, so we have 3 divided into 0.5 groups. Well, if I look at this here, if I say, well, if I make the dividend 10 times bigger and the divisor 10 times bigger, very quickly this becomes an easy problem. 30 divided by 5, I don't even need to bring these things out to check it. 30 divided by 5 is 6. Okay, so I took the dividend, made it 10 times bigger, the divisor 10 times bigger, and I know that the answer, based upon the patterning that we worked on the day before, is going to be 6, and so this answer is going to be 6. In this case here, okay, what would I have to do? Well, in this case, let's see, I have 2 of these. I'm trying to break into 0.25 groups. Well, let's see, if I multiply both by 10, I get 20 divided into 2.5 groups, or 2.5 groups. And that's still, well, you know, that's still kind of fuzzy. How about if I multiply this by 100? If I have 200 of these, can I break them into 25 groups? And yeah, that's very doable. Okay, so that'd be 8. So the answer here must also be 8. Okay, now students may not believe this. You know, we're doing a lot of stuff abstractly right now, so I want to check this. Now, what we want to do is we want to use the second model for division. The one model we've been using up to now is 3 divided by 0.5 groups. Okay, and what we had to do is we had to multiply it by 10 to get it to something where I could use that model, use that idea, 30 divided by 5 groups. In this case, the other thing we could ask the students, what's the other way of looking at division? And the other is, like for example, 36 divided by 4 is how many 4s are in 36. Okay, so in this case I could say how many 0.5s or 5/10 are in 3. So you have 3 wholes. How many 5/10 are there in 3 wholes? Okay, well, you can see I could have 5 here and 5 here, so there's 2. 5 here and 5 here, there's 4. And 5 here and 5 here, there's 6. So I can get 6 of these out of 3, and our answer does say 6. If we have 2, and we want to know how many two 5s I can get out of, or 25 hundredths I can get out of this. Well, if we look at this here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this corner here is 25 hundredths, 25 little cubes. So this corner here, this corner, this corner, this corner, I can get 4 out of here and 4 out of here. I can get a total of 8 of these out of here. Or I could lay this on top if I wanted to and put this and line up the 5 here. Okay, do the same thing. Okay, so there's 2 and 5, and then there's 5, and there's 2. And then 2 and 5, and then 5 and 2. Again, I get 4. 4 out of each one, or 8. So this thing is working. Okay, so now the final step is, okay, we've been doing this in this format and horizontally. What are we doing here? How can we use long division to solve this problem? Okay, so let's just mirror what we did here with long division. So we had 3 divided by 0.5. We couldn't solve it that way initially. We had to turn it into this. We had to multiply this by 10, multiply this by 10. If I multiply 0.5 by 10, it's the same thing as moving this over. And put the decimal point there, same thing as moving it over. 30 divided by 5 is 6, and the answer is 6. 2 divided by 0.25. Again, we couldn't just multiply it by 10, which would be here and here. We had to multiply it by 100 to get an even number of groups. And when we do that, 200 divided by 25, that I could solve. Okay, will this work with a decimal divided by a decimal? Like how about another problem, 0.86 or 86 hundredths divided by 0.2 or 2/10. Now we got decimals in both. Okay, so I'm going to take 86 hundredths and divide it into 0.2 groups or 2/10 of a group, and that's kind of difficult. So how about if I make the group an even number, multiply that by 10 to get two groups, okay, and multiply this by 10, and so now I get 8 6/10 divided into two groups, and suddenly, again, that's very understandable. So 8 of these, 6 of these, divided into two groups. You can see I'm going to have 4 of these and 3 of those. Okay, and by long division, this would have been okay, I needed the number of groups to be a whole number. That's what I did up here. So I'm doing it down here. So this becomes 2 into 8 6/10. Okay, I don't have to rewrite it. Okay, and then just divide it. And how do I divide this? Well, I ignore the decimal point. I think it's like 86 divided by 2. Get 43, and then I count for the decimal point, 4 3/10, and sure enough, if I take 0.86 or 86 hundredths divided into 0.2, okay, so that would be okay, and now I'm using the other model. I'm saying how many 0.2s are there in 0.86? Well, I'd have, here's 2/10, 2/10, 2/10, 2/10, and what is this? This is 3, 6. Okay, so what I'm going to need is 3/10 in each one. Oh, I'm sorry, we have 4 groups. So how many groups can I get out of it? 4 groups, 1, 2, 3, 4. And then how much of this is in this group here? Well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, that's 3/10 of a group. Okay, so that's the way we would introduce this. And over the several days, or maybe even the course of a week, we would get the students to where we have be able to divide a decimal by a decimal.